Good morning. I'm Yun. I'm a student from East Department, and I'm doing a project called FeedBack Keyboard this summer for Mechanical Engineering Department's HapX Lab. The musical synthesized keyboard today can very accurately reproduce the sounds of the acoustic counterparts, as well as the sound of the wide variety of other instruments. However, they cannot reproduce the feel or touch response of the acoustic instruments. And one ME450 team were asked to design a force reflecting keyboard with adjustable touch response ranging from the synthesized keyboard to a grand piano last semester. In this summer, I have rebuilt their model with new interface board and software. Some additional variables and sensors will be added in the testing. We use eddy current as the force actuator. The eddy current brake design consists of an electromagnet with a gap in it, through which an aluminum disc rotates. The motion through the magnet's field induces a current within the aluminum, which in turn reacts with magnetic field and produce a reaction force. My work is to adjust the torque by controlling the speed of the disc and the current in a coil of the electromagnets and the width of the gap, which changes the magnetic field intensity across the disc. This is the prototype of the former design. This is the detailed rendering of the former team. The National Instruments NI deck is the interface, and we use LabVIEW to drive the deck to read the position of the key by the HapX sensor and generates analog outputs to control the speed of the disc and the current in a coil, which control the magnetic field intensity. In this summer, I substitute the NI deck with Sensory Model 626 interface board, and I use C code as the software driver. I use Sensor 66 because it can directly read the encoder as it has higher sampling frequency. And I use C code because it is more flexible and more transparent. It needs only it needs fewer resources, and it has simpler data structure, which make it more efficient than LabVIEW. And I can easily modify the inner logic, the input-output range, the data structure, and even the way of human interface by modifying the C code. Furthermore, the C code is compatible with other activities in the lab, including some magnet arms and other haptic devices. In this summer, I have made a circuit and written a C code to read the encoder of the motor, reading the analog input and generating the analog output to control the speed of the motor and the current, which adjusts the magnetic field intensity across the disk. I've tested the high-frequency sensor and the load cell and made a loopback test of the new system. In the coming month, I will use new magnetic material such as mu magnets to increase the magnetic field intensity, and I will redesign the electromagnets has its adjustable gap, so I can find the relation with the force and the gap and the width of the gap. Thank you.